Hello everyone, today I'm going to talk about circuits and devices. We use it everywhere. We use it in our homes, we use it in our laptops, mobiles, everything. Circuit is just a network. Like this network, it's a network in our home. There's a network that supplies current to us so that we can use it to rotate our fans, to light up our bulbs and everything else. Electricity has many sources. It can come from the fossil fuels, it can come from water, from wind, from air. Now, the general principle is that if you take any power plant, heat energy is usually generated from some mechanism or another, and it's transferred to water chambers where water is boiled to steam, and the steam runs turbines. Now, when the turbines are linked with a long coil of with a long coil, and the coil is rotated in a constant magnetic field. Now, when a coil is rotated in a uniform magnetic field, the amount of magnetic field lines passing through the coil vary continuously, and this variation produces magnetic electric field in the coil. Now, this is known as Faraday's law. Now, when the electricity is generated, it has to be transmitted to our homes. But in order to reduce the loss of energy during the transmission, we have to increase the voltage of the current generated. For that, we have several systems, or particularly a transformer. You have step up transformer and step down transformer to increase the voltage and decrease the voltage respectively. When current passes through a coil or a loop or a wire, it produces magnetic field around it. Now, when you have the primary current generated in the generator, the current is of the type AC, meaning it oscillates continuously. It's an alternating current. Therefore, the magnetic field associated with this current also oscillates continuously. Now, when this is linked with the secondary coil, as it is done in a transformer, the magnetic flux linked to the secondary coil continuously changes, and that induces a current in the secondary coil. But since energy has to be conserved, the amount of current passing through the secondary coil is inversely proportional to the number of turns of the secondary coil. And then this way you can control the voltage or the current passing through the secondary coil. And hence you have several transmission lines that transfer current by stepping them up and again stepping them down when they come close to your homes. There's obviously going to be a lot of loss during the transmission and creation, and hence you usually get a total efficiency between 30 and 50%. These transformers, like the step-up transformers, are also seen in chargers, for instance. The voltage that our homes have is around 240 volts, but it's stepped down in a charger to between 6 and 10 volts. Now, even tube lights have something known as resistors. They have resistant coils that resist the flow of current, and hence they heat up due to the resistance and light up. Even tubes work in a similar way, except they have something known as a ballast that has an inductor in it that can control the flow of current passing through it, because an inductor has a resistance proportional to the frequency of alternating current through the circuit. It also has a switch, a starter switch, that creates something known as an inductive shock that creates an arc in the discharge tube for the flow of current. Even fans work in similar ways. Now, in a fan, you have a special thing called a motor. This is just this diagram of a simple motor. When alternating current passes through a loop of wire in a magnetic field, it rotates. This comes from the principle known as Biot-Savart's law. When line charge of current is experiencing a magnetic field, it experiences a force that's a cross product of the current and the magnetic field. Since it's a closed loop, the net force on the loop would be zero, but it experiences a torque. Now, when you come to phones or laptops, it's just these simple circuits along with some other electrical components, such as the transistors, that work together in complex systems but still follow the same fundamental laws of electric circuits. And this completely other set of circuits is known as digital circuits. Now, digital circuits, along with analog circuits, make up everything that we see around us. Thank you all, and this video has been made by J. Roshan Nayak, Shashwat, and Apurv.